Hello, everyone. Welcome to this session on developing a Matlab code for a stability analysis problem. Before going into the Matlab code, we will first learn in sections how to convert an equation into a Matlab code, how to get the inputs, how to display the outputs, and how to write an equation for generating a graph and how to plot. So after learning all these things in splits, we will finally combine everything into an organized code so that we can learn how to get the output and also what to infer from the output. So first thing is I'll teach you how to convert a mathematical equation into a MATLAB code. So all the equations which here we are going to work are related with the stability analysis problem. I have already shared a video explaining a sample stability analysis problem. So if you have any doubts regarding those equations, the values which we use here, please have a look at those video and come back to this video to get a clear understanding. So the first equation which we are going to take is PM, that is mechanical power is equal to E into V divided by X into sine delta. This is the general formula. Now, here usually we will call this portion EV by X as P max. Okay. So now from this, I am getting two equations. What are they? One is P max is equal to, it is E V divided by X. This is first equation. Now, second equation is I want this delta. So how to find out this delta? So delta is equal to sine inverse of, it is Pm divided by Pmax. So to write a MATLAB code for this equation, it is very simple. You have to use a variable denoting this. Usually, if we have P suffix max, we cannot use suffix or superscript in the subscript or superscript in the MATLAB code, but it is better to have the similar words so that it will be a readable code for anyone who looks at your code. So I'm just see how I'm going to convert this into a MATLAB code. This one is a mathematical equation. So I'm going to write it as P max equal to, first I'm going to take the numerator. So it is E into V, the whole thing divided by X. And for this equation, you can, this is a logical or a mathematical symbol. So we don't have symbols in the MATLAB, right? So we have to use some English variable. So it is better use the name of that symbol. It is delta. So I write it as delta. So since we are talking about the initial value, so I'm going to have it as delta underscore O, meaning delta naught. It is not necessary you have to use the same naming conversion. Whichever is okay for you, you can also use it. So I'll, instead of delta, I'm going to name it as delta underscore naught. That is equal to, for sine inverse, we have a logic, we have a syntax called A sine. So if you put A sine, that means it is sine inverse. So A sine of, it is PM slash P max. So now two lines are ready now for the MATLAB codes. Now similarly, we will go one by one. We will learn how to convert this into equations. Now next heading is synchronizing coefficient PS. So to write the MATLAB code for this, it is P S is equal to P max. So it is P max. For multiplication, you have to put an asterisk. So P max into cos of. So we use the symbol no delta underscore naught. So I will write cos of delta underscore naught. So this is your MATLAB code. And for natural frequency of oscillation, so for Wn, let me use the symbol capital W small n so that it will be very easy and refer it. So Wn is equal to, you have a square root, right? So you have to write the syntax sqrt, square root of Square root of what are the items in numerator? You have pi, f naught, and ps in the numerator. So I will multiply all those things pi. For pi, I'm using the letter pi into fo, that is f naught, into ps. So numerator is over. So the whole numerator you have to divide it by h and then close the square root bracket. That's all. This is the equation. And for damping, so usually this is we'll be using zeta, no? So for easy reference, let me use z as zeta. So z is zeta. First you have d by 2, right? So that you put it separately, capital D slash 2, and then close it. And then you have to put an asterisk symbol. Then you have a square root. That means SQRT of, take the numerator first. Numerator you have pi into f naught divided by denominator. Also you have two terminologies. Again, open a bracket. It is h into ps. So now together to make a bracket for this, and for everything you have to put a square root. This is the corresponding equation. For damped frequency of oscillation, you can have WD is equal to, we use the letter WN into square root of, so SQRT of, you have 1 minus zeta square, so it is 1 minus, for zeta it is z, square means you have put an upward root, then 2. That's all. This is 1 minus zeta square. Suppose if you want in hertz, it is nothing but FD is equal, you all know the formula for hertz is FD is equal to, it is omega D divided by 2 pi. So you can convert that it as FD is equal to WD slash 2 into pi. That's all. Next, for the time constant tau, let me use the variable. I'll use the same. Let me take it as time constant TIMECONST equal to, I'll use this formula. It is 1 divided by zeta z into Wn. That's all. This formula is over. And for this theta is equal to, for cos inverse, like sine inverse, we used a sine. For cos inverse, you have to use a cos of zeta. That's all. So with now finding out all these things, you can directly, now we have, that's it. So we have learned how to write the how to convert the mathematical equation into an equivalent Matlab code. So this is over. Now we will see how to display the values. So look at this. Suppose now look at this. I have given the line. So this is, oh, there's nothing but the part of Matlab code. Look at this. Here it is. PS is equal to P max into cos delta naught. So this is the formula we used here. PS is equal to P max into cos delta naught. And here we use the formula. It is Wn is equal to, it is square root of pi f naught PS divided by h. Correct? So this line and this line tells you the equation. So we have converted the mathematical equation into an MATLAB code. Now you have another command called disp. So disp is usually used to display the values. Suppose if you use a single quotes, okay, so whatever string you provide between the single quote, that will be outputting as such. So it will be printing as such. Synchronizing coefficient comma PS equal to, it will print as such. Now here, so now here what is happening is, so here first step is you are just calculating the PS. You are finding out the calculating the PS. So it will calculate and store, it will store the value in this variable. Then you are asking the system to display this. So it will display synchronizing coefficient comma PS equal to. Then you are asking to display the variable. So you are writing disp of PS. So whatever value stored in this PS variable, that will be printed to the screen. This is another example where wn is calculated and the value is stored in this variable. This is an interactive line which will be printed as such, and this is the line which will print the value present in this variable wn. So now we have learned how to write a MATLAB code for the mathematical equation, how to print out those values to the screen. Now we will learn how to get the values from the user. Now we have learned two things. Here we have learned disp is used to print or display the output. Now we want to get some values from the user. So for that we have another command called input. So we have another command called input. So when you write input of, okay, in single quotes, whatever value you give, that is an interactive feature. It is used to display to the user so that the user can know what value has to be given. So whatever you give inside a single quotes, that will be printed as such. If you put an input, this will wait for the user to give some input. So when the user gives some input, that will be stored into a variable that you mention it here. Okay. For example, you take this equation. So you have written f naught equal to input of enter the system frequency. So when you run this program, it will prompt this line, enter the system frequency, and it will wait. So suppose if you give 50, what happens? That 50 will be stored into this variable called f naught. Similarly, it will ask the next line, enter the transient internal voltage E. When you give this value, that will be stored in the corresponding variable E. So if you want to get any input from the user, you have to use the command called input. And whatever value you get from the user, that has to be stored into a variable. So the general command will be variable equal to input of. And the prompt should be inside your single quotes. Now we have learned how to get input from the user. Now next thing is we will learn how to convert the equation used for plotting the graph. Now look at this equation. This is given as the motion of the rotor related to the synchronous revolving field is. Here they have directly just look at. I'll tell you how simple it is. So first thing is we'll first convert this into an equation. So it is very simple. Just see. So this delta is denoted as rotor underscore. So this is the variable used to denote delta. So this delta is nothing but rotor underscore del. Okay. This delta naught is this one. This is delta naught. And you have a plus sign here. And this is numerator. No, in numerator you have del delta naught. So this is del delta naught. This one. And divided by. So divided by. This is square root of 1 minus zeta square. Okay. Into, so you have an into here, and then this e power minus zeta omega and t is written as like this, exponential of minus zeta into omega and into t, and this term is written like this, sine of omega dt plus theta, and everything is converted into degree, so I'm writing it as 180 divided by pi. Okay, so this is the overall conversion of equation. The only important and the new change that you have to note here is this one. That is this. It is not simple. You cannot simply. It is not simply del. It is not simply a star. It is actually dot star. You all know that this dot star indicates the vector multiplications. Why? Because here you have a variable t, and similarly you also have a variable t. So this is the variable which we are going to use it for plotting. So this will have a set of values. It will have an array of values like this. Similarly, this will also have an array of values like this. So when you put dot, it will be multiplying vector by addition, element by element. Okay. So this dot is very important. You just check it. What happens when you run this program without dot or with dot? But here this dot is important. Similarly, the next equation is given by rotor angle frequency omega naught. So here This portion is given here. Look at this. Numerator you have W omega n into del naught. See, omega n into del naught divided by root of 1 minus e square divided by square root of 1 minus e square into exponential term into sine omega dt into sine omega dt. When it comes to t, you should not use it a single star. It should be dot star. Once this is over, then this equation comes here. It is f equal to f naught minus this term, that is this variable divided by 2 into pi. This is how you have to write the equations. Okay. So when you next we learn how to plot this. So for plotting, see, for example, I'll just tell you a simple, you just understand a simple example. Suppose you have an equation y is equal to 4x plus 3. And if you are asked to plot, if you are asked to plot like this, what you will do, you will take x along x-axis and y variable along y-axis. Now you will be giving some values for x, right? So say for example, you'll give 0. When you put 0, it is y equal to 3. When you put x is equal to 1, it becomes y equal to 7. When you put x is equal to 2, 4 2s are 8, it is 11. So then what you will do is you will plot this 0, comma 3, 1, comma 7, 2, comma 11. Then you will be joining this, correct? So you require points. You require points, no? Similarly, here we are very much concerned about two diagrams. One is, sorry, we are concerned about two diagrams. One is what is delta and one is what is frequency. Let me take it as f naught. So it is taken over an x-axis called time. So like see for x you require these many points, no, 0 1 2. Only when you give so many points for x you will get some answer for y, and using that range you can plot it. Similarly, to plot this graph I want to give values. I need to give values for t. Okay, so that is why what I'm going to do is look at this curve. These are the equations. This is rotor angle equation and this is omega equations, above which I am going to have a range called t is equal to t naught. So what is the meaning for this? That is, if I put t is equal to 0 to 3, that means t will have only these values 0, 1, 2, and 3. Okay, so only 4 values for t. So when you use only 4 values, you will be getting only 4 values, 4 value pairs like this. 1, 2, 3, 4 for delta and omega. So when you plot this graph is not going to tell you anything, no? It won't tell you anything clearly. So I want more number of points. So what I'm going to do is instead of t to 0, I am going to write it as t equal to 0. And here it is incremented by 1. 0 plus 1 is 1, 1 plus 1, 2, 2 plus 1, 3 like this. Here instead of that, I'm going to increment by 0. So you can see that there will be so many points, no, 0, 0 0.01, 0 0.02, 0 0.03, etc. up to 3. So you'll have large number of points. So you'll get large number of pair values. So in that case, if you plot it, you will get a very clear graph. So with this arrangement, we will learn how to use the plot. So now we have got all the equations. Now you can see this. Uh, Now you can see this. We have this is x-axis, no? This is used as x-axis. And this is used for y-axis, rotor underscore del. That is for delta and f. So what is the plot? Usually we'll do x comma y, no? Similarly, I want to plot t comma rotor underscore del. That is one curve. Next, I want to plot this. This is for one curve. Second plot is I have to plot between T and F. That's all. So you can see these two lines here. Plot T comma F and plot T comma delta. So grid means if you put grid, what happens? You will be getting box lines. You'll be getting grid lines in the graph. These are the interactive features. You can give X label here itself, Y-axis name, title of the graph, all those things. Okay. And why do we have subplot here? Because subplot means you will have you can have multiple graphs in a single uh, graph. So in a single window you can have multiple graphs. Here we are going to have a single window having two graphs, so two rows and one column. That is the logic. Okay, so this indicates this 2 comma 1 comma 1 means this is rows and this is column. So if I put t comma, I mean, sorry, if I put one, so I'll tell you how the graph is. The graph looks like this. So this is your window. So how many rows? Two rows. So this is two rows. How many columns? One column. So this is first row, second row, and first column. So this is two rows, one column, and the first row. So here, first graph will be coming. This is comma t comma rotor del graph will be coming here. If I put two, that means t comma f graph will be coming here. You can have a look at this. See, this is a single graph window where you have two graphs. This is graph one and this is graph two. So here, whatever values we have given as X label, Y label, all those things will be appearing here. Okay. So since we have now learned the code in splits, now I'll show you how the entire code will look like. Just have a look at this. This is the entire MATLAB code, complete MATLAB code for doing a stability analysis. First, you have to get all the inputs, the system frequency, internal voltage, bus voltage, mechanical power, inertia constant, all these things you get input from the user. I am going to calculate each parameter, synchronizing coefficient, and I'm going to immediately print that itself. So do all the values calculations and then print out all those values. And here I'm going to use the plotting method. So here I'm going to find out the pair values used for graph plotting, and this is plotted here. So when I look at this, so when I run this, it will prompt like this. So these are the values I have given it from by referring a problem in Hardy's audit book. The explanation of that problem is given in the video link that is I have provided in the description box. So when I input all these values, I'll get all the calculated values like this, and finally this graph. So, so at last, one thing which you have to learn is, see, initially the variation of rotor angle is initially what happens. Initially there is a disturbance of 10 degree. So what happens now? It is 10 degree now. Now the rotor angle oscillates like this, increases, decreases, increases, decreases like this, and finally the variations. That is variation means delta. The variations goes to zero at this point. Say t equal to 2.5 seconds. It settles down. Now, when this rotor varies, see, the system frequency initially it was 60 hertz. The frequency also varies. See, it drops down, increases, drops, increases like that. And when this settles down, this also will settle down to the original value that is 60 hertz. That means if the system fault is cleared within this 2.5 seconds, that means the system can remain in stable mode. Thank you.